you for joining my session at Conference 42 JavaScript-22. Over the modernized large-scale healthcare data engineering platforms from CMS to 77 claim submissions to AI-driven validation pipelines that process millions of transactions daily. My goal today is to share how modern JavaScript frameworks traditionally used in web apps can be repurposed to bear-ready modular EDI 837 validation systems. So this talk cites the interaction of healthcare data compliance, ETL engineering, and software architecture. So finally, you will see how a lightweight JavaScript core can scale to enterprise level edition with the performance, agility, and transparency our industry demands. So let's go and deep dive into the project. What is the healthcare claims and what is the current state and what is the impact? So let me go to the current state. So healthcare organization handles millions of claims each month. So each one must satisfy hundreds of business and compliance rules under the ANSI X12 837 standard. So the ANSI X12 standard is a separate format which we develop the files to CMS, which has a different structure and large elements and they need to be satisfied. Then only the file is going to be processed by the CMS. So the challenge is not only the volume. Claim formats differ between institutional, professional, and dental types, and every pair adds its own edits. So, in many environments, validation is still manual or semi manual, relying on rule spreadsheets or legacy engines written years ago. So, when new regulations arrive, updating the systems can take weeks, sometimes months. So, the results high rejection rates, delayed payments, and mounting costs. So, staff spend hours correcting data instead of focus on patient care or analytics. So this stage, the stage for a new approach on that's agile, rule driven, and technology neutral. And now, what will be the impact? So, a rejected claim does not just impact accounting; it disrupts the entire revenue cycle. For example, if you are sending a file to CMS with 5,000 claims, and one claim just filed because of the structure or some missing elements, the whole file will be failed. So what happens is when we get a 99 written file in which we need to check and see what is the failed component, and then we need to figure out whether it's a strict structure issue or it's a data issue. And then we need to send a claim. So sometimes this may take one day, 2 day, or weeks or months to figure out, because if it's a data issue, we need to figure out from where the data is coming, need to update the data from the source, and then it should flow through the system. So that's the reason what happens. The study says is studies show that 15 to 20% of the claims are denied of first submission, and roughly one third of those are never recovered. That's billions of dollars lost annually across the US healthcare system. So each denial, when a claim is sent which a denial, triggers a chain of manual tasks. We need to review, correct them, and resubmit, and often take 30 to 45 days to resolve. It may take more also, so not only certain time. So meanwhile, provider cash flow suffers and client suffers where the amount is not going from one flow to the other flow. So by building smarter validation layers that detect errors before claims reach the payer organizations can reduce denials by up to 70%. So validation is not about compliance, it's about financial stability and operational efficiency. So, why is the JavaScript a centric approach for an approach for validation? So, modern JavaScript frameworks offer unprecedented flexibility for building healthcare validation system. Unlike monolithic solutions, a modular JS architecture enables rapid iteration, easy maintenance, and seamless integration with existing infrastructure. This approach leverages declarative business rule engines that separate validation logic from implementation details. Developers can define rules in human readable formats, while a framework handles execution, error handling, and performance optimization. So, the metadata driven designs means validations rules live as configuration rather than hardcode logic, enabling business users to participate in rule management without requiring deep technical knowledge. So, what are the core validation capabilities that we are going to use in this AI driven 837 transmissions? So, the four things we are going to do is eligibility verification, provider credentialing, date logic validation, coding accuracy. So, let's deep dive. what is eligibility verification, what is provider running, the other two things. So let's explore the core validation capitals and make this framework powerful, practical for healthcare users. So we begin with eligibility verification. In many claim systems, errors start because patient coverage is not verified in real time. Here is a JavaScript layer connects directly to payer API, confirming active coverage, benefit limits, and service eligibility before a claim ever leaves the provider system. Think of it as an instant checkpoint that reduces preventable denials right at the source. So, if anything is missing or anything is wrong in the claim, so in the initial verification itself, we don't even send the claim to the CMS. So that way we initially check from our system and then we rectify that and then we deliver to the CMS. That's how we save the time and money. And next is provider credentialing. So this step automatically validates NPI numbers, licenses, tax money codes, and worker status using data from NPs or CAQH directories. So when a provider's license expires or they're out of network, the framework flags it immediately. So manual lookup, no surprise later. So that's fair. If any NPI is missing or NPI is wrong or NPI address is missing or NPI is unknown, issues may be present in our system or but when you're directly calling the APIs from NPs or CAQs directories, so that way there will be always active and there will be always a primary address and physician address and also the secondary address for those NPIs. So there will be a little very little chance of failing the claim with the missing NP or missing address or missing tax money codes. That way we can figure out the issues before sending it to the CMS itself. So then we have data logic validation. This is where hundreds of common timeline errors are caught. It checks that dimension dates come before discharges, that the dates of birth is realistic, and that services fall within timely filing limits. Suppose if an encounter happens in something of 2024 December, but he is enrolled somewhere in 2025 due to the system entry or something. So basically, the claim will not be accepted because of some data entry or somewhere some mismatch has been happening. So we need to fix the date logics also. So these small details often make or break claim acceptance. So the last comes the coding accuracy. The engine cross-checks ICD-10 diagnosis, CPT procedures, and HCPC's codes against official code sets and modifier rules. It even supports pairwise logic. For example, making sure a CPT code that requires a certain modifier always includes. And every claim, whatever we are submitting CMS, should have a CPT code which is valid. So these CPT codes or ICD codes, every year CMS changes of your risk adjustment, your non-risk adjustment. Few sometimes every year CMS also says few ICD codes are written. So we need to make our system to be always updated. So that's the reason we bring it to the configurations and we add as a validation check so that we don't submit the invalid ICD codes here. And the CPT code should be a valid CPT code. And collectively, these modules form a 360-degree validation shield. They don't just detect the problems, they explain them clearly so that building teams can act. So now we'll go to the architectural design. So now let's step back and look how all these capabilities fit together technically. So at the bottom sits the data ingestion layer. The component reads raw EDI 837 files, those long test streams full of segments and loops, and converts them into structured JSON objects. Once that happens, every downstream service can read the data like standard key value pairs, frizzling with EDI syntax. So, as we told in the beginning, the ANSI X12 837 structure. So, that structure is very tough to read unless who has a lot of experience in the healthcare system or in the claims level. The system has a lot of loops and structures that no one could understand easily. So converting into a JSON object that makes the user to read easily and they can find out what data elements are missing or some segments are missing. So now next go to the rule engine core. This is the brain of the system. It pulls the right set of the rules based on the claim type, payer, and line of business. Because the rules are metadata driven, you can add, remove, or prioritize them without touching the code base. That flexibility is crucial when regulations change. So what happens is every year, as we told, like ICD codes will be changing, some NP ICD codes changing. Sometimes some codes go from risk adjustment to non-risk adjustment codes. Some ICD codes will be retiring. So all these, if made as a configuration, that would be easy for our system to maintain. So then we have an integration service. So these are external connectors that reach out to third party APIs or databases. For example, to verify eligibility or NPI details in real time, all of them run asynchronously, so fast even under heavy loads. And finally comes the response handler. Once validation is complete, this module formats the results to JSON, XML, or flat file and routes them back to clearinghouse, data warehouse, or BI dashboard. So what's this? So once everything is done, all the validations are done, all ICD code verification is done, integration service is done. What this is again, the JSON changes the its file to the 837 standard file format, and then send the file to the clearinghouses, and the clearinghouses will send the file to CMS. And same data we can use in your dashboards and the warehouses. So the entire design follows a microservice philosophy. So each component scale, fail, or evolve independently. That makes it future proof for cloud deployments on AWS Lambda, Azure Functions, or Kubernetes. So now let's go to the how, as we discussed before, there are like three multiple claim types. So out of them, they are institutional, professional, and dental. So when you go to institutional, hospital and facility claims with complex billing hierarchies, revenue codes, and service line details requiring sophisticated validation rules. So, what are the rules they are having? Revenue code validation, movement board logic, and discharge status checks. So, same way when you're coming to 837 professional claim generation. So, physician outpatient services claims with procedure codes is a mandatory thing. Procedure modifier should be matched, and place of survey requirements needing precise validations. This shows what requirements for institution, what requirements for professional, and what requirements for dental. So in the professional, also place of service rules is a mandatory and modifier combinations. So because as in the COVID, we got telehealth. So we have for a telehealth, we need to specify we're having specific modifier. Then only the CMS knows this is a telehealth claim. If it's not, if it's something like blank or no, the CMS knows okay, it's not a telehealth claim. It's an electronic or genome assessment. That's how they we can figure out how it is. And the rendering provider checks. So whether the NPI is there or not. And coming to dental 837D, dental procedure claims with tooth numbering, surfaces, and specialized coding requirements unique to dental practice management. So it's tooth surface valuation, CDT code accuracy, treatment plan logic. So each claim type requires specialized validation rule while sharing common infrastructure components, making modularity essential for. So now here comes the real-time and batch processing. So once architecture is set, the next question is how do we run it effectively at scale? That's where our dual processing approach comes in. Let's go to the real-time API validation. So process claims as they are submitted through RESTful APIs with sub-second response times. Ideal for clearinghouses, integration, practice management systems, and immediate feedback scenarios where providers need instant validation results. So the API layer supports both synchronous and asynchronous patterns, allowing system to choose between immediate responses or queued processing based on complexity and volume requirements. Now, get into the batch processing engine, how it works. So, it handles engine volume claim files during off-peak hours with parallel processing, perfect for end-of-day submissions, large provider groups, and scenarios where throughput matters more than immediate response. So, the batch engine optimizes resource utilization through intelligent job scheduling, automatic retry logic, and comprehensive error reporting that groups issues for efficient remediation. So, end of the day, what I want to say is this two mode design properties flexibility, real time for instance feedback, and batch for large scale operation loads. So, together they make the system both fast and reliable. So, critical qualities in a 24 by 7 healthcare environment where always the data processing is going to be done. We can also do for the further preparation of AI integration. So, once we have a metadata driven foundation, we can seamlessly add AI capabilities without rebuilding anything. So, the first step is intelligent rule adaptation. We can train machine learning models on historical claim outcomes to identify patterns. If a certain rule generates recommend turning it or merging it with contextual conditions. Over time, the frameworks learns from experience. So the second is predictive analysis. AI models evaluate incoming claims and estimate the likelihood of payer acceptance before submissions. So high risk claims can be flagged for manual review. Suppose we are getting a high risk diagnosis code or claim or HCC, we just make it as flag to double check and then we send it to CMS. So while low risk ones flow straight through. So this reduces manual intervention and accelerates payments life cycles. The beauty is that the AI components use the same metadata as the rule engine. So the results remain traceable and auditable, a must in regulated industries like healthcare. So in a healthcare, any claim you submitted or any once after you submitting the claim, if you return the returns and the ICN, everything needs to be auditable because it all depends on the federal and state government regularities and everything, each and everything need to be audited. So we can also use for future ready extensions. The validation framework can integrate with blockchain networks to create immutable audit trails of claim validation decisions. This transparency builds trust between payers and providers while ensuring compliance with regulatory requirements. Smart contracts can automate certain validation steps and trigger payment workflows when claims meet predefined criteria, reducing processing time and administrative overhead. So, decentralized validation rules can be shared across the healthcare ecosystem, creating industry wide standards while maintaining organizational autonomy. So, let's go through as we wrap up this session. Let's pull everything together and reflect on the key ideas we have covered. First, JavaScript has evolved far beyond its front end roots. In this framework, it becomes a powerful engine for healthcare data integrity, fast, modular, and complexity customizable. Its non blocking runtime and rich ecosystem make it perfect for real time. And modern JS frameworks provide foundation for building scalable 837 validation that adapts to changing business requirements without architectural rewrites. Just based on the configs, we can do this. And second is metadata driven design, separate rules from the codes. Business users can validate can manage validate logic through configuration, reducing IT dependency and accelerating response to payer rule changes. Third, API first architecture is what ties it all together. It lets these validation capabilities plugs seamlessly into clearinghouse, practice management systems, and payer gateways. So whether data moves in real time or in 90 batches, the system behaves consistent and predictable. So fourth is the AI ready foundation unlocks strategic transformation. AI brings predictive intelligence, learning from past outcomes to flag potential denials before they occur. So while blockchain introduces verifiable transparency, eliminating disputes and building trust between payers and the providers. What it does is, so if anything feels it's like it's a high risk code or it seems like it's a highly billable code. So before sending it to CMS, we just take a stop, flag it, send it to double review. And once it is review is done, we send to CMS that way. If it rejects, it takes a lot of time to again redo this. So it's better before sending, we do as a mechanism, we build a mechanism where we can check before sending the claim to the CMS. So ultimately, this approach transform this approach transforms validations from a routine compliance checkpoint to a strategic capability that drives financial performance, operational efficiency, and patient satisfaction. The bigger message here is that technology choices matter. When we design systems that are modular, explainable, and intelligent, we future proof not only our software but also the organizations that depend on it. Thank you again so much for being part of this session. I encourage you to experiment to think differently about where JavaScript fits you in a data engineering world and to connect with and you can connect with me on LinkedIn for continued or further discussions on the healthcare. Thank you so much for giving this opportunity.